Hi, it's Mr. Baumgarten here with a slightly different video. Today I want to talk about the subject of computational thinking. Just the name sounds hard, right? So what is computational thinking? It is a set of thinking strategies that will help you be able to write larger and more complex computer programs. Once you've started to learn how to program and you can solve some of the simple exercises, it is computational thinking that will enable you to take the next step to design and write what you might start now to think of as proper programs. So in this sense, it really is a fundamental skill to develop. So let's take a quick look at what the four-step process for computational thinking entails. Decomposition, breaking the large problem into smaller, easier subproblems. Pattern recognition. This is looking for repeating sequences of steps. Number 3, abstraction. Fancy word, it just means removing unnecessary complexity so that you can create a model, a mental picture that will work for any set of inputs. And then number 4, design your algorithm. Bring together the various pieces back into one whole unified set of steps, like a recipe. For a cookbook. It works exactly the same way. So the example I'm going to walk you through. If I have a set of numbers that I want to sort, or at least that's the problem I'm wanting to solve, being able to sort any set of numbers. The very first step, decomposition, I want to start with a simple reduced scale human solvable version of the problem. And the reason I do this is so that I can figure out what the steps are. If I can figure out the steps for a small version of this problem, then I should be able to scale it up for any size version of the problem. That's the hope, that's the intention. So I've got some cards here and I want to sort these. And I know straight away by looking at this, okay, I'm going to grab the 2, then I'm going to grab the 3, and then I'm going to grab the 4, and so on, and I can very quickly sort that just mentally in my head. That's not hard to do. What are these steps that are involved? I need to actually start thinking, okay, I'm not just doing this just for this little small given problem, but I'm doing this as a representation, as an example of the larger picture of any set of numbers. How can I sort them? So what were the steps that I took? And so I might want to write out my steps and figure out, okay, this is what I actually did. So let's just change my screen back to... Okay, so I might write out the steps, and this is what I did. I found the 2, and I moved it to a sorted set. Then I found the 3, and I moved that to a sorted set. And then I found the 4, and I moved that. And then I'd find the 5, and so on and so forth, until the problem is solved. Now, the step of abstraction, though, requires me to remove unnecessary complexity, because it is only this particular example of the problem where I have a 2, a 3, and a 4, and a 5. Maybe I might have to sort sets of numbers that don't have 2s, don't have 3s. I need a set of steps that works for any set of numbers. And I don't want to have to just imagine every possible number that might exist between -1,000,000 and +1,000,000 and be writing out a million if statements. Okay, if there's a number 1, then that goes first, and then if there's a number 2, then that goes next. And that doesn't even account for decimals and whatever else. So what was I actually doing when I was finding the 2? How can I simplify this or make it generic so that it will work for any problem? And what I was actually doing when I was picking the 2 is I was finding, not a 2, but I was finding the lowest value. And then I moved it out of my set and into the sorted set. Then for the 3, well, once the 2 was gone, 3 was the new lowest value. And so, again, I was finding the lowest value, and the same with the 4. I found the lowest value that remained, moved it onto the sorted set, and then for the 5, that's also just finding the lowest value that remains and moving that into the sorted set. And so looking back here, I can see, well, hang on, one of my steps for computational thinking is pattern recognition, and there is a very clear pattern happening here. Every 2 lines, I'm repeating the same steps. And I know as a beginner programmer that there is a thing called a loop. And this strikes me as an ideal type of loop. I'm just doing the same thing over and over and over again. That's what loops do. So let's turn this into a loop, and this helps me create an abstraction. I'm removing complexity because this only works at the moment if there are 4 different values. I can do a loop that works for any number of values. So maybe I want to turn this now into, while unsorted values remain, what do I want to do? And I'm going to make this Python-y style, but I'm writing it in English, not in Python, you notice. Okay, but I'm using indenting instead of the curly braces of Java or something like that. So while unsorted values remain, I'm going to find the lowest value. And then I'm going to move that, it to the sorted set. And so now I can get rid of this, and I've come up with this recipe that would solve my problem. This will create my sorted set of cards. And what I've actually done is I've taken my one original problem, sort numbers, and I've divided it into 3 subproblems. What I've done is I've used decomposition. I've taken the larger problem and I've created 3 smaller, easier to solve subproblems out of it. So let's take a look at each of these. While unsorted values remain, how do I know if there are unsorted values? Okay, I might only be a beginner programmer, but I know enough to realize that if I'm storing my values in a Python list or a Java array or some other similar programming construct, that I can easily just query that array or that list for how many values are in it. And so if the number of values in my list is bigger than 0, then I know there are items that remain. So I know that that's easily solvable. I don't need to dissect that and break that down into subparts any further. I'm happy to just code that one straight away. In fact, let's do that. So let's end this big quote section. And so let's create a while. If I'm doing this in Python, while values is bigger than 0. That's what it's going to look like in Python. All right? I might actually take these 3 steps, and let's take it out of this big string and make them into individual sublines with quotes. And then what I'm going to do in my Python program is I'm going to put the programming line underneath each one. Okay, so that's problem 1 sorted, and I might need to have some values. So let's just create some values to represent my set of cards. So one thing I will just quickly do with my cards, if I'm wanting to treat this as if I'm sorting a set of numbers, King, Jack, Queen, and Ace are not numbers, they're something else. But I know that normally in a deck of cards, the Jack comes after the 10, and then the Queen comes after that, and then the King, and then the Ace. Well, actually, it depends what card game you're playing, but let's say the Ace comes after the King. So when I turn these into numbers, I'm going to turn the Jack into 11, the Queen into a 12, the King into a 13, and the Ace into a 14. So let's write up these set of values and see where that takes us. So, Keep switching to the wrong one. Okay, so let's create some values here. So the king is first, so that was 13, then the 10, then the jack, then the 2, then the 3, then the 5, then the 7, and then the 6, then the queen, which was 12, then the 8, then the 9, then the ace, that was 14, and then the 4. So I have my set of values, while unsorted values remain. Okay, so while the length of my values is 0, find the lowest value. Right, so how am I going to do this? This is, right, lowest. Now this is where, if you are comfortable with the idea of programming functions, I want to say to you, this is the time where you might want to consider creating functions for your subproblems. Right? Whenever you're diving into, wanting to think, okay, well, this is a complicated step, and I'm going to have to think this one through, and I know it's going to be multiple lines of code. Let's turn it into its own subfunction. So let's just create a function here called find lowest value, and I'm going to put my values array into that. Now this thing doesn't exist yet. I have to create it. So I'm going to jump up into my program above all of this main code and just quickly create this function, find lowest value, and it's going to have values going into it, and it's going to have to return a number. Let's just make it 0 for now. We'll come back and we'll figure this out later on. All right. And then the last thing here, move to the sorted set. So I'm going to need a sorted set of values. I know how to do this one in my head as well. Now, the only reason I'm not going to use the word sorted, because I've seen here this has gone purple, and I'm thinking that that's Python giving me a hint that this is a special word in Python. So just like we can see here with how len went purple. So I'm not going to use the name sorted. Let's call it results. So I realize I need this set. So I'm going to create an empty set for my results. And again, I know I can do this in my head. Results append lowest. Right, and so now, okay, well hang on, this will add it to result, but it won't move it. I need to, moving is a two-step process in itself actually, isn't it? So if I'm breaking this down into subproblems, I need moving a value is actually two things. It is, all right, let's remove from values, and then it's add to results. All right, so there's the add to results part. How do I remove from values? Okay, again, I know enough about lists in Python to realize I can just do remove lowest. That will work for now. This might cause problems if I have duplicates of the same value, but we'll come back to that later on. So let's find the lowest value. That's really what I'm left with now. How do I find the lowest value? Well, what was I doing? Let's come back to this. I've got this set of cards, and I just grab the 2. And I need to be aware that this is a human version of the problem. And because it's so small, it's just easy. I can just intuitively go, okay, there's the 2, that's what I want. But this is just a small scale representation of any potential problem. What happens if I had 1,000,000 cards? What would be the strategy that I would use if I had 1,000,000 cards here? That's what the real question comes down to. And so what I might do is I might say, oh, okay, I'm going to start with the king and work my way down the list. Does anything... Let's compare it to the 10. Is the 10 lower than the king? Yes, it is. Okay, so that's going to be my new selected card. Is the jack lower than the 10? No, it's not. Is the 2 lower than the 10? Yes, it is. Okay, that's going to be my new selected card. All right, and so I'm going to have one card that I'm thinking, okay, this is probably the lowest. Now let's keep going just in case. Is the 3 lower than the 2? No. What about the 5? No. The 7? No. The 6? No. The queen? No. The 8? No. The 9? No. The ace? No. The 4th? No. This is my selected card. This is the one I want to remove. And so I have now found the lowest card. What did I do? I looped through all the values. All right, and I started with the first one, decided it's my selected one, and it compared it to the next one. And if it was lower, then I decided, okay, that's going to be my new selected one. Okay, I know how to do that. That's just a loop. So let's come back to my code. So if I've got some values, my selected card is just the first one. Fair enough. And I can use a while loop or I can use a for loop. Which one should I use? Let's use a for loop except the for loop in Python is slightly different to how it works in other languages. I might stick to a while loop. Okay, current position. Let's do this. Position. All right, so we started on card 0. While my current position is less than the length of value, so while I haven't hit the end of the list, if the value at my current position, keep mistyping, is less than my selected, I might change this. What I'm thinking in my head is, do I actually just want the lowest value, or do I want the position of the lowest value? Because that might solve my potential problem down here for duplicates. Let's leave it as it is for now. Okay, selected. If it's lower than selected, then I want that to become my new selected. Oh, and this is values, not value. Make sure you stick to the same names. Alright, so if the value of my current position is lower than what I've currently got selected, then that becomes my new selected. And then when I'm done, I'm just going to return selected. Right, well, to be honest, I think we might have it. Let's just print results and see what this does. So I'm just going to jump now to this other screen that kept on appearing by mistake and run my program. And nothing's happening. I think we're probably trapped inside some kind of infinite loop. Yeah, we are. I know exactly what's going on. So let's break out of this and come back up here. And while current position, we're not actually increasing current position. Alright, so once we've looked at current position, if it's not, then we need to move on to the next one. So current position is equal to current position plus 1. Now, if you weren't able to just spot that in your head, alright, and you're just getting this blank screen, what you might want to start doing is a little bit of a debugging strategy, is just start printing a whole bunch of values. Alright, so we could have said print, okay, a hint, when program runs and never quits, you're probably trapped in a loop. So go to your 2 loops and find out what's going on. Alright, and in this case, if this is the question that I'm asking the loop to solve, then let's print both of these out and see what their values are. So current position is equal to current position, and length of values is len values. Alright, so I could print that one out, and I might print this one out as well. Print length of values. I don't need to print the 0 out. I think I know what 0 is. Right, and now if I run this, let's go back to this other one. Okay, I'm getting these outputs, so I can be looking through this and figuring out what's going on. Well, hang on, my program just finished, and hey, look at that, I have sorted my list. So I didn't need my debug statements in the end, so I can now remove those print outs. But that's a handy little tip there about how to debug it. Okay, I can see what length of positions. My current position was then incremented 1, 2, 3, 0, 1, 2. And there's my sorted problem. All right, so working through your 4 steps: decomposition, pattern recognition, abstraction, and algorithm design. So take your large problem, break it down into smaller subproblems. Look for repeating sequences of steps. Remove the complexity so that you can figure out the pattern or the model that will work for any size of the problem, right? Because you're going to start with a simple human reduced version of the problem. And then once you figure out each of the individual little sub-steps, you can bring it together to create the algorithm for the whole problem. I can come back to my other window now, and let's tidy this up a little bit. All right, I can remove some of these comments now if I want. All right, and that looks a lot cleaner. I could even turn this into its own function. All right, let's just quickly do that. Sort values. And so I'm going to select all of that, indent it, and then just return results. And now I've got one function that should work for anything. So I had these values, and I said results is equal to sort values. All right, rather than doing all that, let's do this. Let's just stick these in here. All right, so I'm providing that parameter, and in fact, I can even really just simplify it all the way. All right, because it is just a function call. Okay, if I print out these sorts of values, it will still work as I expect. And if I could run back to the other, running my program, there we go. I have my values. Last step, let's test that it works for other values, shall we? So print sort values, and then I'm going to give it a list of values, and there's my 2 closing brackets, one for sort values function, one for the print function. So let's just pick some random numbers. I'll pick the same one. Let's go higher. Let's throw in a negative. 5, 73, 10,000, or negative 14, and 8. All right, let's run that. So save, go back to the other screen. So it's going to sort the first one, and then it's going to sort the other one. Okay, so we got the answer to the first one, and now the answer to the second one. Minus 14, minus 10, 5, 8, 13, 73, 90, 10,000. I think we might have cracked it. Hope that helps. It comes with practice. but it is a useful set of steps, and the more you practice it, the more confident you'll become. Okay, so break your problem into larger steps, look for the patterns, simplify, start with a human solvable version of the problem. I can't emphasize that enough. All right, and then once you solve each little step, bring it together and you solve your whole. And then test it on something else. All right, this is Mr. Baumgarten signing out.